Botflies are an annoying problem in the temperate and tropical regions. They are parasitic, and in places that are temperate, they will fly onto the host and plant their larvae, which will bury their body into the host and feed off the host's mass. In the tropics, however, the botflies are too loud to just land on a mammal. They have to use stealthier tactics. They will attach their young to something that comes into contact with mammals often, like a female mosquito. After the botfly has attached the eggs to the mosquito will go and deliver the eggs for the bot. The larva egg will detect the heat and hatch into the host, and implant itself into the host's skin. Once it's in, it's a real pain to get out. They dig into your body with two hooks, and it only makes it worse to try to pull it out. No matter how the larvae get put into their host, they will grow for several weeks, and eventually burrow out, forming a cocoon that will help them develop into adult botflies. Here is a video of a botfly larva being removed.
This woman, Vanessa, found out the hard way. She returned from a trip to Belize carrying a very unwanted souvenir.
Oh God, he saw it.
A bug in her head. First, she tries to smoke it out, to no avail. Next, a high-tech medical remedy. Tape over the larva's breathing hole. And the worm emerges.
It's kind of stuck.
Sort of. Yes, that was living in a woman's scalp. If they never encounter tape and a pair of tweezers, the botfly babies eventually come out on their own. If allowed to eat their fill, the larva will burrow out to pupate. But this is one baby that no one would want to keep.
Ow. Oh God, that hurts.
Even the botfly.
The giant cowbird, Scaphodura oryzivora, is a type of brood parasite. It lays its eggs in other nests and lets the other species of bird raise its young. Some of its eggs look very similar to other bird eggs, so they fool the victim nest into keeping the egg and raising the chick. Cowbird chicks develop much more quickly than other birds, so they have a large advantage. They use this advantage to starve their fellow nestmates, enforcing the parents to constantly collect food for them. However, some cowbirds don't try to fool their host. They will storm into the nest and lay multiple eggs. Here is a video of a cowbird breaking eggs of a host that rejected the parasitic eggs.
It takes months, but slowly, a pattern begins to emerge. Only the nests with big openings are getting ransacked.
And over a number of years, the patterns became really, really clear to us. That, oh my goodness, we've actually got experimental evidence that female cowbirds are really doing this stuff.
Sure enough, those small-holed nests cowbirds couldn't fit into were 100% safe. It's the most compelling experimental evidence ever of an animal besides us exacting a mafia-like retaliation.
My first reaction was, oh boy, they're way smarter than we thought.
And they even caught the whole thing on tape. With quick, sharp stabs, the female cowbird does the dirty deed. Within seconds, the entire warbler brood is destroyed.
We had really nailed it. But then, why would they destroy the contents of the nest? What does that do for the cowbird?
Perhaps it's a power play cowbirds use to force other species into accepting their offspring.
Because the warblers could learn, if you don't play along with this game, if you don't raise my offspring, there's a penalty. And that penalty is that we're going to come back and we're going to mess up your nest.
Some species of host bird will not reject a cowbird egg, even if they know it's not theirs. The reason for this comes right back to the botflies. Because the cowbird develops more quickly, it can protect the host young from any botflies that attempt to lay their eggs, by eating them. This mutualistic relationship happens only if the host species doesn't have a nest near a wasp or bee colony. The wasp or bee colony will deter the botflies, and any cowbird eggs in those nests will be dropped. This shows that not everything is defined, and the world isn't black and white. Relationships between organisms change depending on their environment. There is a species of wasp called the paper wasp that relies on another species of wasp called the Central American wasp for protection. The paper wasp, living up to its name, is a very frail and docile wasp. It relies on the Central American wasp, a far more aggressive and strong species, for protection. This is an example of a commensalistic relationship between organisms. This relationship only applies to the wet season, as during the dry season the trees drop their leaves and the nests are exposed to many predators. This supports the theory that the relationship between two organisms is entirely dependent on their environment. Here is a video of a bird attacking a wasp nest. Dung scarabs have a mutual relationship with parasitic mites. These mites are visible on adult dung scarabs. Dung scarabs have competition when it comes to food. They feed on dung, as do several species of flies. The flies will almost always beat the dung beetles to the dung, leaving their larvae inside it. The fly larvae will eventually eat all of the dung, leaving the dung beetles with no food. Fortunately for the beetle, the parasitic mites that are on its back or legs will crawl into the dung, eating all of the fly larvae, then leaving. The dung beetle can then eat the dung and lay its own eggs inside the dung. Here is a video of a dung beetle rolling a ball of dung.
Dung beetles work together to assemble a suitable dung ball as the centerpiece of their new home. One beetle burrows under the earth to help the dung ball settle in. This aerates the soil and helps the nutrients in the dung ball nourish the earth. Once the dung ball is settled in, the female lays her eggs in the new burrow. When the eggs hatch, they feed on the dung and prepare to begin this valuable renewal of the earth all over again.
This relationship, however, is not always a mutualistic relationship. For nocturnal dung beetles, there are little flies to compete with, so there would be no reason for the mites to be there. And the mites only end up negatively affecting the beetle. Again, you see the change in relationship based on the environment, showing that everything in nature isn't the same everywhere.